Good morning. Today we're going to be continuing our live stream classes on Fusion 360 specifically designed for woodworkers. And today we're going to do something a little more advanced than some of the recent classes have been doing. We are going to look at a few of the more complex tools in Fusion 360, and we're going to get started by modeling a Japanese traditional toolbox. I've done quite a few of these. They make excellent class projects, but we're going to do a very simple one today. So we're going to start by clicking here on our sketch tool, and we're going to start sketching from the top down. We will pick a center point rectangle, two-dimensional, and start by modeling a single straight rectangle. It doesn't matter how big it is, as usual. We are going to click the dimension tool and pick our long dimension. We'll make it 28 inches. Scroll out and pick our short dimension to be 12 inches. So it is 1 foot by almost 2.5 feet. Now that is our outside perimeter, and we are going to click on this twice and hit X to turn that into a guide line. So that is not actually going to be a piece of the toolbox, it is only going to be the guide of where the toolbox goes. Now the interesting part about a Japanese toolbox is that the whole thing slots together with grooves, and you don't need anything but glue to put this together, but we're going to use a few dowels to simplify the joinery. Now, we're not going to do this in the most efficient way possible. We're going to do this in the most visually simple way. So it's going to be a little slower, and I can, at some point, if somebody really wants me to, show a simpler way to do this in terms of getting it done quickly. But I think it is more important that we get it done in a way that makes more sense to beginners. So we're going to start by modeling the sides. We will select a rectangle, and we will draw one of the two sides over here. That's great. Now we're going to draw a center line through our guide rectangle, and we're going to draw a center line through the other way. We will pick both of those by holding Shift and hit X to turn those into guides as well. Now we have center lines to be able to mirror things. I would like to have two sides that are exactly the same, so I will double click on that to select that whole rectangle. Hit mirror, and mirror it across the center. So now anything I do to this top one automatically gets reflected in the bottom one. Now I want to draw another rectangle for one of the end pieces. Doesn't matter how big I draw it. And again, I'm going to select that rectangle, and I will hit mirror, and mirror it across from one side to the other. The other thing that I'm going to need is to draw a line for the outside handle parts. And that line, of course, also needs to be mirrored over to the other side. Now, practically speaking, if you were going to do this the most efficient way, you wouldn't mirror these. You would draw them just as a quarter of the box. But you'd do your joinery that way and then mirror all the joinery. But we're going to do the joinery separately, so that it makes a bit more sense from a woodworking perspective. There's no correct way to do it. This is slightly less efficient, but I think it's easier to conceptualize visually. Okay, so this is generally what the outside of, what the top view of our box is going to look like. The only thing that we have to be very careful of is this little rectangle here. And I'm going to do something else with this rectangle. This rectangle is actually going to be inset into a groove. And if you look at this, it is right next to this piece. Now I could actually go in and remove all of the constraints, but instead of doing that, I'm going to pick that rectangle, and I'm going to pick the other one, get rid of it, and I'm going to draw a different rectangle. Now, why would I want to do that? I want it to be inset in a groove that is inside this outside rectangle. Now the important part about that is that it has to be symmetrical. It's going to fit into this groove both sides the same way. So I could tell it that I want it to be in a dimension on this side and tell it that I want to be in a dimension on the other side. However, it will be so much easier if I don't have to do that if I ever want to change how far into the groove it is going to go. So I will click on this symmetry tool. I will pick one side, the other side, and the center line. and it is now symmetrical. So if I make that box wider or narrower, it goes both directions. Now I think it's time for us to give some dimensions to these objects. We will go to the dimension tool and we will pick that this long side here is going to be exactly 13/16 of an inch thick. We're going to pick that this inset side is going to be the same. So instead of typing it in case we have to change it, I will just click on the other one that we already have and hit OK or Enter. And now you can see that that is the same. I'm going to double click on it and mirror it across the center line. Whoops. Double click on it. Let's try that again. If it selects the wrong thing, just click the X and try again across the mirror center line. And now we have it there. Now how far from the outside is this going to be? We will dimension this from the outside line, and it is going to be 1 inch and 3/16 in from the outside. That's going to be the depth of our handle. Now if you look at this, the only thing that we're missing now is the depth of this groove. So this groove here is going to be exactly 3/8 of an inch deep. And now we have it. This is our top-down view. So let's model some of these components. Our box is 28 inches long by 12 inches wide, and we are going to make the components of this box, other than the top, 9.5 inches tall. So we'll start by modeling the outside edges. Extrude, this tool up here, turn a two-dimensional sketch into a three-dimensional object, and we'll pick the outsides and we'll leave these little grooves so that we don't have to cut those out later. We will say New Component, and we're going to say that this is going to be, what was it, 9.5 inches long. We will hit OK, and we will hold down Shift and drag with our middle mouse button to see that we have created two sides with two long grooves in them. Now, if I open up our sketch folder and turn the sketch back on, you can see we have several other things that need to be put into our sketch. I will extrude just like we did, and I will pick the 3 pieces of each side. Remember, each line that you don't turn into a guideline is going to turn into another division. So that's why we want to make sure that as many things as we can are guidelines. Now, instead of typing in 9.5, in case you want to make this box a different dimension later, we will make sure we only ever define those numbers once. So we'll say To Object and pick the top edge of one of these sides. But instead of joining these together, we want them to be a separate component. Before we get confused, I'm going to call this long sides and short sides. I use the capital letters to divide the words. Putting spaces in there can work, but I try to avoid it whenever possible because it makes it really hard to reference them if you ever have to turn the thing into a full parametric model. Okay, that looks pretty good. Now I want to create the bottom and top support handles. So I will extrude the outside pieces, and we are going to make those exactly 13/16 of an inch tall. And we'll make those a component as well. You can see that that bottom support is there. Do you think that's tall enough? I don't know if that's enough support, so I'm going to right-click on it down here in our history tree and hit Edit Feature, and I'm going to change that to 1 5/8 and make it a much more substantial little block at the bottom. Now, because that's going to get in the way, I'm going to go up here, I'll give it a name, Bottom Handles, and I'm going to turn it off. I will click on those same 2 handle pieces, but instead of starting at the bottom, I want to start at the top. And we are going to go from the top a distance of exactly 7/8 of an inch. But if we zoom in and look, we're going in the wrong direction. Where I actually want to go is down, so I'll change that to be -7/8 of an inch. Select a new component, and now we are going in the right direction. Okay. Now, there are several different schools of thought on how to make handles for these Japanese toolboxes. I'll call this top handles. Turn the bottom ones on, and you can see what this looks like so far. We don't need this sketch anymore for the moment. So this is the end of our toolbox. But I like to make it so that there is a handle in the middle instead of just at the top and the bottom, because the middle handle is really where you're going to hold the thing. Some people like that, some people don't. But I'll turn off the top and bottom handles for the moment. I'm going to turn the sketch back on, and I'm going to extrude one more time. I will say offset from the bottom. We're going to go up 4 inches, and our middle handle is going to be exactly 13/16 of an inch deep. We'll say new component, and I think that looks a little small, so we'll make that 1 1/8 inches. And hit OK. Now we'll turn back off our sketch, rename this component to middle handle, and turn the other two back on. How does that look? I think the bottom one looks a bit thick, the middle one looks a bit low, and the top one, well, we'll worry about the top one after. So I'm going to go to this middle handles, and I'm going to move it up from 4 inches to 4 7/8. I'm going to go to the middle one. If you click on one, it shows you which one it is. I'm going to go to this one here, and I'm going to call it 1 1/16. And I think that looks a little more stable. The only other thing that we have to do before we worry about modeling the top, which is where all the real interesting stuff happens in one of these Japanese toolboxes, is to create a bottom and the joinery. So I'm going to go in and I'm going to start modeling on one of these bottom pieces. I'll drag it up so I can see it a bit more clearly, and this is the piece we're modeling on here, this top piece. I'm going to hit P for project, and I'm going to copy the dimensions of these other 3 pieces right here, and I will hit OK. Project just means that I am taking those measurements and those guidelines and putting them into this sketch, so I can then reference them. So I'm going to take a center point rectangle, and I'm going to draw it. It doesn't matter how big it is, and I'm going to inlay this center point rectangle into these sides. So first I will drag it over, and I will give it a dimension between there, and it is going to be inset exactly 3/8 of an inch. I will drag the other side over, and I'm going to make that again D for dimension, and it will be inset the same 3/8 of an inch. If I have to change it, I'd rather just copy it from the other one by clicking on it. And there we have it. That's all we need. I will click on Extrude. I'm going to go in here and I'll turn all these other pieces off. I will rotate around so I can see the bottom here. And I'm going to pick all the pieces of this bottom so that we will extrude them. And when you select more than one piece, it actually joins them together. Now, we don't want it to just be in one direction because that's right on the bottom. We actually want it to go inset into the bottom of the piece 1/4 of an inch, and we want it to stick out the bottom by another 1/4 of an inch and be a 1/2 inch thick piece. So what I will do is I'm going to say offset 1/4 of an inch, and the distance will be negative 1/2 inch. And we will say new component. Now, if your mental visualization is happening properly, let's rename that bottom, you will realize that this piece is actually going to overlap with our long sides and our short sides in a very meaningful way. You can see that it is actually inside. So what we need to do is we need to cut a little rabbet in those pieces. Easy enough. I will click on this Combine tool, and I will cut one side with the bottom. Keep the tools, because the tool is the bottom. I'll right-click on the background and hit Repeat Combine, and I'll cut the other side with the bottom. We'll just do that 2 more times, one for each of the short sides. As I said, this is not the most efficient way to model this. It would be more efficient to model this as individual pieces in one corner of our box. But I think this makes a little more visual sense. Now, it looks like it's still sitting in there and there hasn't been a change. But if we turn that bottom off and zoom in, you can now see that there is a 1/4 inch rabbet going all the way around the bottom of our box. Let's take a look up close. See our 1/4 inch rabbet here. If we want to make sure that that is exactly a 1/4 inch by a 1/4 inch, we can go in here and inspect, and it is, there we go, 0.25 inches. And we are good. All right, let's zoom out, flip back over so that we can see the top. We're going to turn back on our bottom. And the other thing that we need down here is that it needs to have some feet. So we're going to model by starting a sketch on our bottom. We will draw a center line because our feet are going to be symmetrical. And we'll turn that into a guideline so it doesn't get confusing. We will draw another guideline from one end to the other because, again, we want things to be symmetrical and we don't want to have to worry about giving dimensions on both sides. I'll click on a center point rectangle and draw a center point rectangle. We'll give it a dimension by hitting D for dimension. We'll make our feet exactly 7 3/8 inches long. And again, we will dimension the long side, the short side of this foot, and our short side of our foot is going to be 1 1/8 inches. The only other dimension that it needs is a place to tell it how far in the box it is going to be. So from the edge of our bottom, it is going to be 2 3/8 inches in. We'll double click on that center point rectangle and mirror it across our center line. And all those things are now mirrored top to bottom and right to left. We'll say Finish Sketch and extrude these two pieces. We'll just hide our bottom. And from that bottom, we want to be able to go down exactly 3/8 of an inch. We'll create a new component and hit OK. Now, if I turn the bottom back on, you can see that these pieces are going to be right on the bottom. And we'll call these feet. Not bad. If you're curious why these feet are put on here to make sure that if you put the box down and it happens to be wet or cold or anything that could do some damage to the tools that are delicate inside the box, it won't actually necessarily transfer up. And if you ever have to replace something because it is rotting out from contact, it will just be these 2 feet. And those 2 feet, they're sometimes nailed on, sometimes screwed on, sometimes glued on. We're actually just going to do it with a few dowels. We're going to get to the joinery now in a moment. Let's just take a look at what we have accomplished so far. We currently have 2 long sides, 2 short sides, 2 top pieces, and our 3 end handles. Not bad. Not bad at all. The only thing that I want to be able to do before doing the joinery is to model these 2 end handles up a little bit. So I'm going to go in here and I'm going to use a great function, our chamfer tool, modify chamfer, and I'm going to pick the inside edge of these 2 center handles. I will go in here and say 2 distances, and I'm going to make these go in one direction 1/2 inch, and in the other direction 1 inch. Now, has that actually done anything? Let's see. I'm not sure if that is modeling in the right direction. Let's see if it is doing anything when we zoom in. 1/2 inch up and 1/2 inch over. Have we even selected the right edge here? All right, let's turn off our short sides and our long sides and see what we're actually doing. Sometimes we get a little carried away. So I'm going to make this edge a little longer, and that gives us 1/2 inch by 1 inch of a taper. And we should be able to see that on both of these 2 edges. Oh, that's why it wasn't looking right. They're not both going in the same direction. My bad. We'll turn off these sides and we'll do them individually. That inside edge, and we will make it go 1/2 inch up and 1 inch over. and hit OK. We'll right-click and repeat it for the inside edge of the other piece. 1 inch over and a ½ inch up. They're going in different directions, so it makes sense they're reversed. And the reason we do that is so that we can get a little handhold under that piece. And we want to cut that now rather than cutting it later, because it's going to affect the joinery that we're going to use to hold these pieces to the side of our box. Now, let's take a look at what we can do for that joinery. How are these pieces actually going to be attached into our side? Well, we're going to do that with some tenons. So I'm going to click on the side of one of these pieces, and we're going to draw in some integral tenons. These tenons are going to be small, but these pieces aren't actually going to be holding a lot of support weight. So if I draw a center line from the top of the first piece to the bottom of the last piece, I will hit P for project and copy the dimensions of the other two on. Now, I think that is not quite linking up with that bottom piece. So I will hit coincident and pick the bottom piece, and now it is not moving. So we can hit X and turn it into a guideline. Now, I want to be able to create a center point rectangle right in the middle of this piece. So I am going to draw from the center of one side to the center of the other. I'll do that for the bottom one as well. And in this one in the middle, I am going to give it a guideline for where that rectangle is going to be, but it's not going to be in the center. I will give it a dimension and tell it that it is going to be, whoops, is that not straight? We will have to make it straight. All right, so now the distance between those two pieces. Oh, it's the center point. That's what I was just going to define it to be. It is the center point anyway. So it goes from the center of this line over. Now we are going to draw, after making these guidelines, three integral tenons. We will make them rectangular, and we will give them a dimension. They're going to be 3/8 inches tall and a ½ inch wide. You're not going to see these on the outside. The show ones are not going to be rectangular. They're going to be square. But I'd rather make these a little shorter because the pieces that they are being attached to are actually quite short. So I will draw a center point rectangle again, and I will draw a third one down here. Now I want those outside edges to be the same. So I will click collinear, and I will pick one outside edge and two. And I will do the same thing between the middle and the bottom. So we transfer that dimension all the way down. Now I want to make the heights equal as well, so I will say equal height of one and height of the other. I will copy that to the bottom one, where we will use the same height of integral tenon. One copied, two, oops, I copied it to the wrong one. Equals one side, two sides. Now we have three exact copy integral tenons. Now we have to add that to all the other pieces. So instead of cutting that in or joining it on, we will hit extrude, and we will click on each of those three, and we will create a new body that goes out. And how far is it going to go out? It's going to go out a ½ inch, 1/2 inch. So we'll just say new body. Now, those are the integral tenons that we're going to be cutting on the edges of those pieces. But we need them on the edges of all the others. So I will say mirror, just like we did in the sketch. I'll pick those three and mirror them across the center line. Those are in this bodies folder right here. So I will say mirror again, pick all 6, and mirror those across the center line, and now I have 12. Now once that's put in there, I can click on this combine tool, and instead of cutting it, we're going to join. We'll join the first one to its integral tenons. We'll repeat and join the second one to its integral tenons. 1, 2, 3. Again, we will repeat I picked the wrong one, so I can just hit that X, scroll down here and make sure I do pick the right one. Rotate around and pick the other integral tenon. If you can't select something, just zoom in and make sure that you can. We'll do that again while we can see it. I want to connect this middle piece to the outside two tenons. Where is that third piece? There, that's the third piece. Just keep moving around until you find it. Now we have the three on that side. Let's turn the bottom off to make it a little easier to select things, and the feet. And I will repeat, top, left, right. Okay. Top, middle, left, right. And one more time for bottom, left, right. You can see why it is more efficient to do this mirrored, but this is totally fine. And when you actually go down to make this piece, you're going to have to cut these things in one at a time anyway. So now we have to cut the tenons that we have into the sides. So we'll do that. We will, instead of joining, use our combine tool to cut our side. And if we take a look at these, we're going to cut it with 1, 2, 3, 4, 5, 6. And you can see those now have their tenons on them. And we'll say keep tools. And we'll repeat that on the other side. 1, 2, 3, 4, 5, 6. And if we turn off those handles, we can see that we have cut the tenons, the mortises for each of those tenons into those sides. So those will come together quite nicely. The other thing that we want to do is we're going to cut some tenons and mortises for these center pieces. Those are sitting in grooves, but that is definitely not enough. So I will turn off our long sides, and I'm going to do the same thing and model some tenons that are not going to be integral. These are going to be floating tenons on the side of this piece. So I'll go to the side of the piece, and again, I want these to be in the middle, so I'm going to draw a guideline right down through the center of this piece and hit X. Let's turn off our bottom and our feet again so they don't get in the way. And we can see that we have this nice little groove cut into the bottom. That's not going to interfere with this at all. So I'm going to go into this center point rectangle, find the middle. You can see it gives us this little triangle. I wish it was a little more obvious, but I'll draw that, and I will hit equals and make the top and side equal so it is a square. I'll give it a dimension by hitting the dimension tool, and we're going to call this exactly 1/2 inch. If I say finish sketch, we will now extrude that, but we're going to turn on the outside long sides and say that that piece isn't going to just go a distance, it's going to go to the outside edge of our toolbox. And instead of being flush, I like these to be about a 1/16 inch proud. So I am going to say new body and hit OK. So we can see that we have that tenon protruding through. Now I will say create pattern, rectangular pattern, and pick that one, because I want to make a whole bunch of these. We are going to pick a direction. Our direction is going to be up and down, so we'll just pick it on our axis, and we'll drag that up. Now, I don't want there to be 3 in one direction. I actually want there to be several more than that, and I want them to be symmetrical. So we will pick symmetric. We are going to say that instead of 3, we want 5. How does 5 look? And I want them to be a little further apart than that. So they are going to be 3.5 inches apart, and there are now 5. That will give us a nice strong hold, but more importantly, it will give us a beautiful decoration for the side of our box. Now we have these 5 bodies, and we are going to use our mirror tool to copy them across our center, and we will pick all 10 and copy those across our center line as well. So now we have all 20 of those. But those are going to be floating tenons. So they need a component of their own. We'll say new component, and we will say floating tenons. Actually, we're going to call it short side tenons, because we might yet need to use some other ones. I'm going to pick all those bodies that we have up here, and you can see that it selected them in our model, and drag them into our short side tenons. I'm then going to go back and start and keep modeling on our whole model. Some people really like modeling inside the components. Other people like modeling as the whole object and dragging things into components. I tend to be in the second school of thought. One isn't better than the other. For large projects, I will model in the components. For small ones, I will tend to model in the other ones. Now, we're going to use a few other components to simplify this piece. We're going to say a new component, and we're going to use a component for handles. We're going to create another component and call it, we're going to call it lower. Into the lower one, we will put the bottom and the feet. Into the handles one, we will click and drag the handles. And we are going to create 1/3 main component for organization. And we'll call it sides. And we will put the long sides, the short sides, and the tenons that connect them into our sides component. And we will now hit the main one and come back. We'll turn back on our bottom and feet. So now, if we look at this as a component, we can turn on and off the lower, the handles. I forgot to turn them on in the first place. The handles and the sides, all as one click, which makes the whole thing a little simpler for us to deal with. Now, we have a fully functional toolbox with one tiny exception. It doesn't have a lid. So the interesting part about a Japanese toolbox is that it has a lid that doesn't lift off in the traditional way. It actually clips in to make it easier to use with a wedge system. So what we're going to do is we're going to model here on one side and draw the outside edges. So we are going to make an outside box for it to clip into. We will click and create a rectangle up here and give it some dimensions. We hit D for dimension, and that upper rectangle is going to be 11/16 tall. It's going to be quite short. And it is going to be exactly 1 7/8 of an inch. Let's try that again. I will double click on this dimension, 1 7/8 of an inch long. Now, that's not long enough to get all the way into the inside of the box. And this is one of the great things about modeling. We can see that that sounds like it's going to be quite a long piece, but it's really not long enough. Make it 3 1/8. And that is going to get us well within. We make it 4 5/16. And we get to the actual dimension on our plans for today. It doesn't matter how many times you make a change. Everything just follows those changes. Now, we are going to need to duplicate that across our center line. So we will draw our center line. If you're seeing a theme here about mirrors, there is a reason for that. Double-click on our rectangle and mirror it across our center line, just like we've done many times before. Now we have that on both sides. On one side, we need to have another piece. And our other piece, we are going to give it a dimension. And the dimension is going to be 1 3/16, which is not too bad. We'll worry about that and how it looks in a minute. It might be a little small, but that's not something we need to worry too much about. Now, over here on the first one, we need to actually draw an angled line, because this is going to be part of our wedge system. We're also going to go over here to where that was, and we are going to draw another rectangular box. And that will be the outside edge of both the wedge and the wedged support piece. So I'm going to draw 2 more lines, the inside wedge line and the outside wedge line. They're going to be parallel to each other, and the other part of the wedge support is going to be straight and flat. Now, if we continue to model on the back of our piece, this calls it the back, it's one of the long sides. All we have to do now is give these some dimensions. Let's give that an angle. From that line, we want that angle to be exactly 80 degrees. We're going to make the angle going the other way also the same. I think that looks pretty good. That is the traditional angle for these. I've always liked it to be a little more acute, so I'm actually going to change that to be 68 degrees. And we need to give a dimension between these two. This is the offset between the inside of our tapered wedge and the outside. That angle is usually given as that dimension is usually about 3/16 of an inch. And we will give a dimension that goes from one end of our wedge to the other. This is the short end of our wedge. We could dimension it either way. And I'm going to say that the wedge itself is going to be 1 5/8 of an inch wide on its short end. The only thing we need to do now is give an overall dimension of this piece here. And we are going to say that that is going to come in exactly 7 inches into our box. Now, if we go over here, that's not going to look very symmetrical. So I'm going to get rid of this. And instead of giving that short dimension, we'll give a different one from the outside to the outside, and we're going to make it the same as this one. It doesn't have as much complexity on this side, but that's nothing to worry about. All right. So now we have those pieces. The only other thing that we need to do now is worry about getting our other block in. So the other piece that we are going to use will go from just inside this edge to just inside this edge. We are going to tell it how thick that piece is. It is exactly 3/16. I think that's a little small. We're going to call it 5/16. And we are going to say that that is offset inside. Let's go to our back, zoom in. It is going to be inset inside exactly 3/16. On this side, we're going to make it a 1/4 inch inset. And now we have all the pieces we need to start modeling our wedge top. So, we will take our outside piece, not that one. We will take our outside piece and click on it. We'll do it at the same time with the other one. And instead of giving it a dimension, we will say to Object, go over to the other side and pick the other long face. And we will create a new component. Hit OK. Just so we don't get confused, I'm going to call that component outside top. We will turn back on our sketch and do the same thing. Oops, not for that one. We'll do it for this one, the one on the right. And we will go to Object, again, to the other side. We will say New Component and hit OK. And we will call that Inside Top. We're going to put another one in there in a minute. Now, we need to have another sketch over here to sketch the other side of our wedge pieces because they are tapered. So I will say New Sketch. I'll explain this in a little bit more detail in a moment, but for now, just try to follow along. I will hit P for Project, and I will project the top, the bottom, the left, the right, and the inside edge of our wedge onto this side. And now what I need to do is combine the outside edge from the other side with the inside edge on this side to create a two-way tapered wedge. Now, if I say create, and I say, oh, no, we have to finish the sketch. If I say create, that's why it's not there. If I say create and I say loft, and I pick the bigger version of the wedge on this side and the smaller version of the wedge on the other side, I'll zoom in and pick that other piece, it is now going to draw me a wedge that goes from the big version to the small version and make a tapered wedge. I will say new component, and I will call that wedge. I'm going to go and do the same thing. Whoops. I will hit create loft from the outside of our component to, turn our sketch on, to the larger version on this side. You can see how tapered it is. And we will say new, we'll just say new body. Because we already have an inside top to put that in. And we can turn off these sketches. Oh, wait a second. No, we haven't actually drawn the top. We'll go over here and extrude our top. And that top isn't going to go from that outside edge. It's going to go from the object, the inside of our box, distance, to the other side of the inside. But instead of joining it to anything, we will call it a new component. And we can see now that we have drawn this thin top panel, and that's exactly what we're going to call it. We're going to say new component, and we'll call it top. We'll drag all of our top pieces into our top component and go back to modeling on the main piece. We'll turn off those last two sketches, and we are done with our sketching. Now, we have done most of our joinery already. The only other joinery that we need to do is to connect this top piece on each side to our main box and to connect our inside pieces to the top. So let's do that. What I'm going to do is I'm going to do again these floating tenon, extruded floating tenons along the top of this piece. So I'm going to model on the top. But I want these to be in line with these already existing tenons. So I will draw a center line right through the middle of this top piece. And I am going to draw a center point rectangle. Doesn't matter where I put it. I will click on this guideline and turn it into a guide. I will click equals and make it a square. And then I am going to make it collinear with both outside edges of that other tenon. I don't have to give it any dimensions at all. Whatever the dimensions are of that one are copied to the left and right side, and because it's a square, they are copied all the way around. Not bad. Finish sketch. Now, I want those to go all the way through this top and into that center piece. Now remember, that's in line with the center of that side. So it's also going to be in line with the center of that side on the top. So all I have to do is hit extrude, extrude that one thing, and we are going to say new component. We will say offset, and we are going to offset it exactly 1/16 of an inch up. And it is going to go 2 inches down into our box. We'll say that's negative. And if we scroll over here, we can see where it's going to be going if we turn off our sides. You can now see that that is going down. Not bad. The other thing that I need to do is I need to copy that. So I will say, no, not mirror. I will say rectangular pattern. I will click on this body. I want it to be going left and right this time, so I will click on the part of the axis that goes left and right, and I will drag it over to the side. Again, we want there to be 5. We want them to be symmetrical rather than just going in one direction. And we are going to make them a little further over than that. How far do we want them to go? Oh, we'll just drag them over, and I think 4.5 inches is about right. The only question is, do they conflict with the tenons we already have? Let's give this a name. We'll call these top floating tenons. Turn on our sides, but turn off the actual sides. We only want to see the tenons. So let's see if they are conflicting with our tenons. I think our tenons might actually be a little on the short side. What do you think? I think that's only going through a very small amount. So I think we need to go back and correct an error that I must have made somewhere along the line. What did I do? I said that that was going to be to object, but I forgot to tell it that I wanted it to go any further. It is from the profile plane, which is the inside edge, outside edge. That's the outside edge of that piece. It has to go deeper into that component. Sorry? Apparently, I'm not making any sense. So, I want it to go 2 sides, and the other side, I want it to go a full inch into that component on the inside. And we're going to say new body. Now, that's one of the really nice things about this. If I correct that, you can now see that all those floating tenons are exactly an inch long. Is that conflicting with our tenons from the top? Yes, I thought it might be, and that was the reason that I was thinking about not doing it in the first place. I was going to come back and do it later, and I just totally forgot. We'll make them 5/8 of an inch long, and now they don't conflict, but they provide plenty of strength. Okay, that looks good. The only thing we need to do with those now is we need to go back and make sure that we actually cut those in. So, our long sides, we'll turn off our tenons and make sure that we cut those in. No, apparently we didn't cut them in properly. So we'll turn back on our tenons, turn off our long sides, and make sure that our short sides are cut. No, short sides aren't cut either. So we are going to cut those. We will say combine, one short side, all the tenons. Cut the other short side. Whoops. Let's pick the right side here, drag it over, and pick all the tenons. Let's try that one more time. The joys of doing it live. Cut that, and we will then turn off our short sides, turn our long sides on, and repeat the same thing we just did on both long sides to cut our tenons through. One long side, rotate around, repeat combine. If you haven't got the hang of this yet, you haven't been here the whole class. So now we have our tenons cut. If I turn off the tenons, we will see that we have holes in our long sides, holes in our short sides. We can turn them all back on and all is good. Now, let's get back to what we were doing. Now that we've checked to make sure they don't conflict and made the tenons the length they're supposed to be, let's take our top floating tenons and copy them to the other side. We'll copy all 5 using our mirror command. And we will go, turn the top off so we can access our center line. That's not the center line. We'll turn the bottom off too. We want to mirror them across here and hit OK. Now, if we look at where these are going in, these have to be cut into, so combined with the short edge. We'll pick all 10. And the other short edge. And again, pick all 10 and hit OK. There are 2 other places we need to cut these in. So we will go and take a look at our top. We're going to repeat that same combine command, and we'll take our top end piece and cut in our floating tenons. We'll do it again with the other end piece and cut in our floating tenons again and hit OK. And now, if we turn off our floating tenons, you will see we have holes that don't just go through here, but go through the side as well where it is going to mate up. We're going to take those top floating tenons and put them in with the top as well so that we can turn on and off the top and it will link in properly. The other thing that we're going to want to do is make some connecting holes to connect in with our other piece. This is our wedge. That's not going to be held in place because we're going to slide that in and out. And the other piece is going to be this section here. Now, if I look at this from the side, this looks like it is not quite full. So I'm going to check on that loft command that we did. That first loft command, I will say Edit Feature. I'm going to get rid of this feature, and I'm going to click on these three from this profile, and then I'm going to go over and make sure that we pick the right profile on the other side. Remember, this is parametric. We can always go back and fix our mistakes. And I say OK, and now it is actually filling in that gap. That wedge is right there, and it goes all the way through, tapered to the other side. Not bad. See how small it is on this side, that end piece? If we rotate around, that end piece is much bigger on this side. And it's that taper that holds the top in. That is the magic of the Japanese toolbox. Now the only question is this piece a bit wide? And I think it is. So I'm going to go in here and edit my sketch number 8. Always zooms in a bit too far. So I'll zoom out, and I'm going to take a look at this sketch. We're actually, I think, on the wrong side here. Where are all of our dimensions? Top? Nope. I don't want the top. Come on. Drag around. What I want is the back, because we modeled it, I think, on the back. Oh, I'm looking at the wrong sketch. My bad. What was it? Sketch 6? Sketch. Edit sketch. That's where all of our dimensions are. And I think it's a little too far in. I think 4 is a bit too big, so I'm going to go in here and edit it. I'm going to change this, just like we always can, to 3 3/8. And it will move both this side, and look at what it did to the other side of our box. It moved the other one in exactly the same distance. So, the only thing we want to attach now, beyond that, is this inside one, and we don't need 5 of these decorative pieces. What we're going to do is we're going to turn off our lower side, our sides, and our handles. Look down here at the bottom, and start sketching on the bottom of our lid. Now I want to project this top piece, so I know where it is. I'll draw a line straight through, so I know where the center is. And I will click that and turn it into a guideline by pressing X. I am going to create a center point rectangle here. And I'm going to click equals and turn that into a square. I will hit the dimension tool, and I will dimension that to be exactly 3/8. It's only going to be small. And I will hit Finish Sketch. Now, we don't want that to be visible from the outside, but it will be a nice little decorative feature on the inside if anybody ever goes looking for it, which is interesting. Now, I think that looks pretty good where it is. What I want to do is I want to extrude it part of the way into this top piece here. So I'm going to say distance, no, to object, to the top. But I don't want it to go all the way to the top. I want to say new component. And I want it to go to the object, but offset 1/4 inch. But I want it 1/4 inch inside, so I will say minus. And so now on the bottom we can see this piece. And I don't think it sticks out. And I'd like it to stick out. So I think that's what we're going to do. We're going to make it go, instead of from our profile plane, we're going to offset it just a 1/16 inch. Have we gone in the right direction? I think we have not. So we'll say minus a 1/16. No, that goes up further. We'll take it down. We'll say OK. And now it is protruding a little bit below the bottom. So it is a nice decorative feature, but it is a hidden decorative feature. We are going to take that and make a rectangular pattern. We will select our direction and make it go, again, right and left by selecting the right and left on our axis. We'll take a look at it from the side, drag it over, and where is it going to be? We're going to make it a little narrower than the other one. We're going to make it 4 inches. We'll make it symmetric, and we'll say that there are, again, going to be 5. They're a little closer together because we're not just putting it through, the outer section, we're putting it only through the inner section, and hit OK. Now we need to copy those 5 pieces, open our bodies, and we will mirror it across the center line. And now we need to cut them in. Doing the same thing, we'll cut our top segment with our 10 bodies. We will repeat and cut this piece, the inner section of the lid, and we will cut this other piece with these 10 pieces. It's not going to be centered, but that's going to be plenty strong once that is glued down. These are really just for show more than anything else. And those are now cut in. We can call this the inner top tenons. And we'll drag that into our top. If we open our top folder and we turn off our top panel and we turn off our inner top tenons, we can see we now have holes cut part way in. So these are blind mortises. If we turn back on our top panel, they are going right through as well. One moment. I'll be right back. Sorry about that connectivity lapse there. We are back, and we are just about finished with this model for today. We are finished with our sketches. We will turn back on our inner top tenons, and we will turn back on our sides, our lower, and our handles. And the only thing we have left to do is think about what to build this from. Now, I have modeled this in maple, because I pretty much do all my modeling in maple, because that is my usual wood for building things. But a lot of people like to make these out of more decorative woods. Now, since this is a Japanese toolbox, we're going to hit A for appearance, and I'm going to change the base wood here. We'll scroll up so we can see it a bit better. And I'm going to change the base wood here to what it would be traditionally in Japan. One of the main traditional woods in Japan is cherry. We wouldn't necessarily have it glossy. I think we'll make it semi-gloss. We'll scroll up and replace all of our main woods with this semi-gloss cherry. And I think that looks really nice, and that would be extremely traditional. However, we can make it even more decorative than that if we really would like to. And instead of doing it that way, we are going to use some ebonized pieces. We will make them dark. And we're going to go in and make all our tenons this stained dark semi-gloss. And that will allow us to make each of the decorative components that way. The only other thing that I would like to do is open our sides, and I'm going to make our short side tenons that way as well, stained dark semi-gloss. And open our handles, and I'm going to make the middle handle, the one that we grab, that same ebonized finish. And I've seen others where a lot of the end pieces and the decorative top pieces are that color. I'm just going to make one other thing that color, just to make it obvious that it can move. Not really for decoration, but just to make it obvious it's a separate piece. And I'll make the wedge that color. I'm not going to use any of that on the other pieces, but I think that just sets it off really nicely. If I scroll up, one nice, neat little feature that we can use to surprise people is instead of doing it just on the pieces you see, we'll open the lower, and we are going to change the bottom, but not the feet, to be that darker color. So if anybody goes and opens the inside of our box, that bottom piece is stained dark. And when you look at the bottom, it will be the same way. I think that looks particularly nice. We will hit close. Of course, making those decisions in the modeling software just gives you a vague general idea of what that's going to look like. If you want to see a more accurate depiction, you can go in here and hit render. That will take some serious time, and I'm going to share a render of this later on after I get a chance to get it built. It takes about 5 minutes on my modeling system. It can take sometimes 2 or 3 minutes on a really powerful one. Sometimes if you have a slower system, it can take 20 minutes, 30 minutes, and if you have a lot of them to do, you can actually pay Autodesk to model them for you. So I'm just going to save this so we can know where it is, just in case any of you want a copy of this model. And that is done for today. All I will ask is that if you have liked this, could you please click like? If you want to see more content like this, live streams and classes on how to use Fusion 360 and more about woodworking in general, click on the subscribe button down below and ring the bell because we do a lot of live stream classes, though this one is live recorded because I don't have any internet connectivity that is stable enough during this snowstorm we are experiencing here in my city. Okay, so thank you for joining us this morning, and have a great day modeling and building in your shop.